Hi, I'm Rob. Welcome to Math Antics. In this lesson, we're going to learn how our basic number system works, and we're going to learn about an important concept called place value. The number system that we use in math is called base 10, because it uses 10 different symbols for counting. Math could use other systems that are based on a different number, like base 2 or base 8, but I'll give you 10 guesses as to why the number 10 is such a popular choice. The 10 symbols that we use are called digits, and they look like this. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. At first glance, you might think that that's only 9 digits, but remember, the 0 counts as one of the digits also. To see how our number system uses these digits to represent amounts, let's pretend that we have an apple orchard full of apple trees, and each of these trees is loaded with big, juicy red apples that we need to pick and then count for our records. We're going to use something called a number place to count. The best way to understand a number place is to imagine that it's like a small box that's only big enough to hold one digit at a time. As we count, we'll change the digit that's in the number place to match how many apples we've picked. For example, if we start with no apples at all, we put the digit 0 in the number place, because 0 means none. But then, as the apples start coming in from the orchard, we begin to count. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, now we've got 9 apples, but we've also got a problem. We've already run out of digits to count with. The highest digit we have is a 9, but there's a lot more apples left to count. What will we do? The solution is to use groups to help us count. If we pick just one more apple, we'll have 10, right? So let's combine those 10 apples into a single group. So, how many apples do we have? 10. But how many groups of 10 apples do we have? Just one. Does that help us with our lack of digits problem? It sure does, if we use another number place. Instead of using this new number place to count up individual apples one at a time, like we did with the first number place, we're going to use it to count apples 10 at a time. In other words, we'll use it to keep track of how many groups of 10 apples that we've picked. For example, if we've picked only one group of 10, then we'll put the digit 1 in that number place. If we pick 2 groups of 10, then we'll put the digit 2 in that number place. And if we picked 3 groups of 10, then we'll put the digit 3 in that number place, and so on. Do you see what's happening? Because the new number place is being used to count groups of 10, it's allowing us to reuse our original 10 digits. But this time, they're able to count or represent bigger amounts. Since this new number place is for counting groups of 10, we're going to name it the tens place. And we'll name our original number place the ones place, because we used it to count things one at a time. And here's the really important thing. We're not going to use the new number place instead of the old one. We're going to use it alongside of the old one, so that we have one number place for counting by ones and another number place for counting by tens. Using these two number places together lets us represent amounts that are in between the groups of 10. For example, if we've already picked 30 apples, then there'll be a 3 in the tens place because we have 3 groups of 10. But there'll be a 0 in the ones place because there are no individual apples left over. But if we've picked 32 apples, then there will be a 3 in the tens place and a 2 in the ones place to represent the 2 individual apples that are not in the groups of 10. In fact, using only our 10 digits and these 2 number places, we can count all the way from 0 up to 99. At 99, both of our number places are maxed out with the highest digits, and we won't be able to count any higher unless we get another number place. If we've picked 99 apples, and then we pick just one more, we'll have exactly 100 apples. And if we make a group from those 100 apples, we can use this new number place to count how many groups of 100 we've picked. That means that we can reuse the same 10 digits again in this new number place to count how many groups of 100 we have. And you guessed it, it's called the hundreds place, because we use it to count groups of 100. Are you starting to see how our base 10 number system works? It uses different number places to represent the different sized groups that we use to count. And the digits in those number places tell us how many of each group we have. The digit in the ones place tells us how many ones we have. The digit in the tens place tells us how many groups of 10 we have. And the digit in the hundreds place tells us how many groups of 100 we have. And have you noticed that each time we got a new number place to count larger groups, we placed it to the left of the previous number place? That's important because number places are always arranged in the exact same order. Starting with the ones place, as you move to the left, the number places represent larger and larger amounts. And did you also notice that each new number place represents groups that are exactly 10 times bigger than the previous number place? 10 is 10 times bigger than 1, and 100 is 10 times bigger than 10. That's really important because it helps us see the pattern for even bigger number places. It helps us to see that the next number place will count groups of 10 times 100, which is 1,000. And that's why it's called the thousands place. And the next number place will count groups 10 times bigger than that. It's the 10,000s place. And the number places keep on going like that. Next is the 100,000s place, then the millions place, then 10 millions, then 100 millions, then billions, and so on. Oh, and you may notice that when we get a lot of number places next to each other like this, it's a little hard to quickly recognize which place is which. That's why many countries use some kind of separator every 3 places to make them easier to keep track of. For example, in the US, we use a comma every 3 number places to make it easier to identify things like the thousands place or the millions place. Seeing all these number places together helps you understand what we mean by place value. In a multi-digit number, the number place that a digit is in determines its value. Even though we only have 10 digits, each digit can stand for different amounts depending on the place that it occupies. If the digit 5 is in the ones place, it just means 5. But if a 5 is in the tens place, then it means 50. And if a 5 is in the hundreds place, it means 500. And it's the same for bigger number places. A 5 in the 100,000s place means 500,000. And a 5 in the billions place means 5 billion. See how a digit's place affects its value? Of course, when we work with numbers in math, most of the time the number places are invisible, but the underlying pattern is always the same. Oh, and because the number places are invisible, in certain cases you'll need to use zeros to make it clear what number you're talking about. To see what I mean, imagine that this 5 is in the hundreds place to represent 500, but if you make the number places invisible, then it just looks like 5 and not 500. So, to make sure people know you mean 500, you need a 5 in the hundreds place, a 0 in the tens place, and a 0 in the ones place. Now you can tell that the 5 is in the hundreds place and it means 500. Okay, now a great way to see place value in action with some actual numbers is to expand them to show that they're really combinations of different groups. When we do this, it's called writing a number in expanded form. For example, we can expand 324 to be 300, 20, and 4. Because the 3 is in the hundreds place and means 300, the 2 is in the tens place and means 20, and the 4 is in the ones place, so it just means 4. So 324 in expanded form is the combination of those amounts. 300 plus 20 plus 4. Let's try writing another number in expanded form. 6,715. We can expand this into 6,000 because the 6 is in the thousands place, plus 700 because the 7 is in the hundreds place, plus 10 because the 1 is in the tens place, and 5 because the 5 is in the ones place. So the expanded form is 6,000 plus 700 plus 10 plus 5. All right, so do you see how our base 10 number system works? Number places are used to count different sized groups. Each group is 10 times bigger than the next, and the digits in the number places tell us how many of each group we have. The tricky part is that the number places are invisible, so you have to know how they work behind the scenes in order to make sense of multi-digit numbers. How do you like them apples? The exercises for this section will help you practice so that you get used to how place value works, which is super important if you want to be successful in math. As always, thanks for watching Math Antics, and I'll see you next time.
That gives me an idea. I could make pies out of these.
Learn more at mathantics.com.